Hi everybody, here's Ben. It's a Friday. Tired. But let's take a look at the binocular suppression scene because this is useful and important for alternating strabismus. At the moment, the alternating strabismus scene doesn't really work because the binocular suppression scene doesn't really work because people with alternating strabismus are seeing with both eyes at the same time, and there's only this portion in the middle which is overlapping, and only that's in conflict, and different people perceive it differently. So there's two challenges. First of all, the binocular suppression scene doesn't work properly in helping us understand how we need to boost the signal to one eye to overcome the suppression, because it's not really clear that we're talking about that central section, and strange things happen. We need to understand what's happening in that central section, because if you have alternating strabism, you still need to have that different luminance ratio to help you with the misalignment measurement and the eye straightening and things. But at the moment, the scene's designed to handle one eye completely on or completely off classical strabism. So we're going to look at what it takes to put in a new example conflict zone so that you can build your own and experiment and find out what works better, and we can maybe generate some new insights. And we're also going to look at how that luminance ratio is stored in the config object, because in general data storage is going to become an issue, and it's important that everyone understands where we are now and how difficult or easy it is to extend that model. So I did talk a bit about this alternating strabismus issue in this YouTube video. I'll try and put a link to it. But first of all, let's have a look at Unity. So this is the binocular suppression scene. Let's take a look at what it's made up of. You can find the binocular suppression scene in the community app. You go into scenes, binocular suppression, and just double click on this scene icon. It's got this EyeSkills VR scene prefab. That's just something you can drop into any scenes you make, so it automatically understands how to do things like asset switching, and it understands about its role inside an EyeSkills app. Okay, you just pop it in there and forget about it. Inside the model, we have the camera rig. Inside the controller, we have the binocular suppression controller. This is a really simple scene, and there aren't actually any scene-specific assets anymore because I moved these conflict things into the camera rig. So in the camera rig, we have the left and the right camera, and we have these things called conflict left and conflict right. So these are the things that you see in each of the different eyes. So in conflict left, we actually have at the moment two different sets of assets. So we have assets for adults and assets for kids. So the asset is named default, and we have left eye in conflict. We can click here on the sprite, which will show us where it's actually located inside the project. And we can double click on it, for example, to take a look at what it is. So this is the arrows. And we have, for the children, for example, they'll see this. Okay. What we're going to do is we're going to add a new asset, which isn't actually that hard. It may be that we shouldn't be doing this on the camera. I'm not 100% sure, because it's a prefab. If we on the camera then click on apply here, it will then be present as a conflict background in all of the scenes, which could be useful, might not be useful. It might be better, first of all, to experiment in your own version, not apply it to all the scenes, and just see how you get along. So let's make a new container here, new game object, which is going to contain our new assets. We just have to, by convention, name this with asset hyphen. So let's call this test. Okay, imaginative, no? And we can actually put anything we like in here. The asset switcher just turns this on or off, which also affects all of the children inside it. So it could be that we have many assets in here. It could be that we have scripts that on enable and on disable actually start to operate. So it could be that these assets, when you select this asset, it's actually a dynamic asset that has extra abilities, and I'll talk about that in a bit, and I'll talk about asset switching in just a second. So first of all, we're interested now in having a new background in the left and the right eye. So what are these things? Well, actually, they're just sprites for the moment. Keep it simple, keep it stupid. So we can do this several ways. We can just add a component. We could copy across the other one, but let's just put in a sprite. In fact, is that the way I want to do it? Ooh, it's been a while. 2D object sprite. There we go. So now it needs to have the asset. These sprites are in the framework, so let's not put it there for the moment. Let's put it inside our community app folder here under sprites. What we'll do is we'll just grab, so I've just built this new example background in Inkscape and exported the left side and the right side, and the idea here is that the participant can actually tell us exactly where the conflict zone is, because they can say, I can see columns from 0 to 4 and from A to F, but then something weird happens from column 6J, they aren't there. I'm seeing it carry on in yellow from column 2 across to column 7, for example, something like that. So we have a left grid and a right grid. I've just exported them as 2048 pics by 2048 pics as a PNG, and we'll just drag, in fact we'll drag both of them across into that folder in Unity. Yeah, so recording the screen and having a 2015 laptop. Yeah. Right, we need to now turn these PNGs into sprites. So we can go here, texture type, and we'll just select sprite 2D and UI. And we need to apply. In fact, I think, yeah, alpha's transparency, that's all fine. I don't think we need the physics shape. Well, that might be useful if we were using reticles or something. Okay, that's done, and same here. I'm just remembering there might be an issue doing it with sprites, because Unity does something odd. Let me just check. Yeah, it looks okay, we'll see what happens. Right, what's next? What are we actually doing here? Fridays. Okay. So actually this might now just work. We're going to pop here in our new sprite, let's call this left eye in conflict for the sake of consistency, and we're going to drag across this left eye, this new left eye grid into the sprite field here. The material, I think here I've done it unlit. Oh no, sprite's default. Okay, let's just see how that goes. And we'll do the same thing down here. We'll add a new game object, sprite. In fact, no, we need to make the assets first of all, don't we? So create empty asset test. I'm going to create a new sprite, and we're going to call that right eye in conflict, right eye in conflict, and then we're going to drag this across to that. We're going to drag that across into this field. Okay, so now we've got a new assets, lovely. Theoretically, if we run this scene now, unfortunately Unity got rid of seeing the scene as if you had the VR headset on. Super annoying, but there we go. We're going to see the default asset. what we can do is, there's a microcontroller which will let us change the assets dynamically. So I think that's the best way to go for now. If you hold down in your Bluetooth keyboard the up key for 2 seconds or 3 seconds, and then let go. Is he not playing along? Why is he not playing along? Or am I just not hearing audio? That's annoying. Why am I not getting that to come up? Ah, mute audio. Hang on a second.
Leaving direct camera edit mode.
Okay, so it was working, just had your audio muted so I couldn't hear it.
Entering direct camera
Right.
edit mode. Scroll up or down 4 options.
So if you press W or X,
Asset swap.
if you press W, actually, it scrolls around the back of this sort of virtual menu. So these microcontrollers are for you to fiddle about with things, give you more control. And the asset swap allows you to select it with E.
Asset swap available.
Right, and now if you press, I think, up or down,
Swapping
yeah,
assets.
so up scrolls through the different assets.
Swapping assets.
So you can do this inside the headset, so you can add as many different conflict backgrounds as you like to try them out, and you can use the microcontroller at any time to switch between them and see what happens. So one issue here, of course, is that I've made the scenes 2048 by 2048, which now, of course, means that we're only seeing C to H, and we're only seeing 1, 2, 3, 4, 5, 6, 7, 8, 9. No, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we're seeing all the columns, that's good, but we're limited to about 5.5 or something in terms of rows. So actually I should remake those assets, but you get the general idea. It would be very interesting to then document your experiences, make little videos about this as well, and explain what it is you see if you have alternating strabismus. And what we could do as well, when you activate, you can see here, because this is running, asset test is actually active while these are not active. It could also cause an associated script to start that, for example, monitors the position of the head. So, for example, as you move the head left, the two conflict zones in the left and right eye move apart away from the center, and as you move your head right, they perhaps come together or even overlap more dramatically. You know, I get a feeling, or perhaps they retreat into the background, or they change relative scale. I mean, you know, obviously the world is your oyster. There's any number of things. If you perceive something interesting, start asking yourself, how can I go after that? How can I nail this down? What happens if it's happening in the context of movement or color shifting or high contrast, low contrast? And try and bear in mind that what we're after is to discover, if we can figure out what's happening in this conflict zone, we want to try to figure out, can this technique of boosting luminance, the luminance ratio, be applied to just those conflict zones? What would it have to look like for you to be able to set that luminance ratio so that we can get that going and then reuse it in follow-on scenes like the misalignment measurement, or watching videos, or doing the hyper-real eye straightening scenes? I don't want to go into that just now, but if anyone's interested, the next step would be to build those dynamic scenes, and then if you ask me, I'll show you how that works another time. Finally, yes, let's take a look at what actually happens. So in the background, this is the binocular suppression controller, and what's happening, and this explains why my laptop's struggling. We're recording the screen and we're playing the scene and the debugger's running. That's probably... What's happening here is that we have this, we're basically following we've written this class, the EyeSkills VR headset input. Okay, so if you follow this and you go to declaration, you'll see that we're tracking the local rotation of the camera that we've told Unity that we're going to track. So let's take a look at Unity. If we come down to the controller, over here we'll see a component. Yeah, here. So we've added this EyeSkills VR headset component, and we've told it to track the left camera. And wait a second. Let me just double check how I've done that. So anything that's a public field is actually presented in the IDE. Okay, so you can drag and drop things into public fields. Okay, right, so what I've actually done is the ratio controller is probably, yes, it'll be looked up because it's a private field. I'm just telling it here which camera object to track. So I've dragged in the main camera left. Probably I should drag in the main camera head because we've kind of settled on that. And then this component figures out what to do with it. And with every update, because it's a kind of polling based approach in Unity, it looks up, where are we? Okay, so here, the ratio controller, it gets a direction which I've mapped to -1 to 1, so looking up and looking down. And actually, inside that ratio controller, we also limit the degrees of freedom, so you don't have to look 180 degrees up or something, or 180 degrees down. I forget what I've clamped it to, but it's a variable you can adapt, and it gives you this output. It maps it to -1 to 1, and we use that as our brightness ratio, and we set the brightness ratio, reporting it if it's changed significantly over the network, so that the server can give you a nice, without it being flooded, it can give you a nice view of what's changing, but we're not going to get into that now. And on the camera rig, it uses this method, set binocular suppression ratio, and passes it that brightness ratio. So if we go to that, depending on whether the ratio is positive or negative, it changes the camera brightness on the right eye or the left eye. Okay, and if you want to know what's happening there, let's have a quick look back in the Unity, and we'll go to the camera, for example, camera right, and you'll see that there's a component on the camera called brightness. And brightness takes a value from 0 to 1. And we'll just double click on there to load up that script. And what I do is I actually I don't just directly apply the incoming 0 to 1. I just put it through a simple power curve to make the ratio more sensitive towards the extremes, because the further you get away from the two inputs being balanced, the more sensitivity you want in trying to precisely find that ratio. And the issue is that the brightness control seems to be non-linear in Unity, so we have to compensate for that and make it more sensitive towards the end of its movement. So that's this part here. I could draw a picture on you'll figure it out. You just draw yourself a graph and you'll understand how it's behaving. And then finally, we either so if we're not ignoring the stillness sensor, so if we're using the head gestures and you stay still, we store the suppression ratio and quit, or you can confirm, which does the same thing, store suppression ratio and quit. So this is where some of the data handling comes in, and I think it's worth having a quick look at that. So if we go to the declaration here, sorry, this is so random and disjointed, it's just yeah, not prepared anything. Inside the camera rig, we have this config object. So let's take another look inside the camera rig. In fact, let's go straight there. And we've defined the camera rig config. So here, the public variable config is a type camera rig config, and camera rig config extends config base. And config base knows about how to store this stuff locally, store it over the network, load it, and do all of the gubbins to make it useful. But this is pretty cool because if you want to make your own config or extend it or do whatever you want to do, you just extend config base and put in some variables, and using some AOP, the config base knows what to do with these things. So this is like the classic set that we use now. We store the binocular suppression ratio, whether the left eye is strabismic, the right eye is strabismic. Again, not so useful if you've got alternating strabism. Maybe we need to extend this specifically for people with alternating strabism to favoured eye, or actually what we do at the moment is we can just say left eye strabismic true, right eye strabismic true, and obviously it's alternating strabism, right? But it's a bit tricky because those values are actually used to define in the misalignment measurement which of the fixation objects is locally mapped and which is globally mapped. So when you move your head, which stays still and which moves with the head. And at the moment, there are a few places where it doesn't know what to do if both of these are true. So I think we need to develop that a bit. We store the left eye misalignment angle as an Euler, as a vector 3. So it can handle horizontal and vertical misalignment, so hypertropia or esotropia or whatever, or exotropia, blah, blah. And we store, and this is very lame actually, the depth perception accuracy. This is just a ratio between, you know, the 10 that have been tested and the number you got right, but we lose all the information about whether it was, you know, 5 in a row and then 5 couldn't be done, or, you know, really we need this to be an array actually. These are minor changes, but they could be quite significant, but the design all depends on what we want to do with the data, right? And we need to move forwards with our data design, I think, now, to be really clear about what it is we really want to find out. And once we know what it is we really want to find out and what it is we're going to store, it's actually as simple as just altering some of these variable types. Everything else happens in the background, don't need to worry about it. And we can then re-extract that data from the server side. And also this least misalignment before fusion loss. This is another very sort of hacky first go. When we do the eye straightening, you can shake your head or you can use the controller to reset the eye straightening, and this is just the best angle that the person managed to get to. But for example, if they managed to straighten up, we should be storing how long did they manage to keep both eyes straight for, how many times did they have to reset, at what angle did they reset. So really this needs to be an array of the least misalignment before fusion loss chronologically ordered, so each new entry is, for example, after a reset, so we can see how many times they've attempted it and what the rate of progress has been over time in each session. Okay, that's really unstructured and I hope in some way helpful. I just do not have enough time to really prepare a script or make this lovely, so I'm afraid you have to put up with my random blatherings. But hopefully this has been helpful in understanding how to extend the binocular suppression scene and how data is managed, so how data could be extended. I'll put the SVG in Rocket Chat so that you can massage it or use it as a base. And that's it. Thank you very much. Bye bye.